This video is just going to be focused on graphing the parent cosine function without any transformations of any sorts. So whether you're new to graphing cosine functions or you just want a little bit deeper understanding of where all the parts are going to come from so that all the transformations make sense too, that's what this video is going to be about. Alright, let's get started. So here's our function of f of x equals cosine of x. And if you want to stand a chance of graphing more complicated cosine functions, you're going to want to really have a good understanding of how the parent function works. While this is the parent function, let's talk about all the pieces that are hidden behind the scenes. Really, all of our cosine functions are going to fit this formula right over here, where a, b, c, and d are going to have different effects on the parent function. The reason why we don't see any of these values right now is really just because of the identity properties. So a in this case for the parent function is just equal to 1, and 1 times anything stays the same. B is also equal to 1, which is why we don't see it as well, because we're multiplying by 1 again. And then C and D here are both equal to 0. So you can see that if you add or subtract 0, we're really just gonna not have to write it because of the identity property of addition. And so we don't write the 1s or the 0s in the parent function, so we don't have any transformations. And so for the parent function, we're gonna say A is 1, B is 1, C is 0, and D is 0. Now in terms of whether there is a vertical reflection or not, that depends on the value of a. If a is a negative number, then we would have a vertical reflection, but in this case a is equal to this positive 1, so we're not going to have a vertical reflection, and that makes sense. This is the parent function. As for the horizontal reflection, that's going to be affected by the value of b. If b was a negative value, then we would have a horizontal reflection or flip across the y-axis. Notice how b is positive here, so we're also not going to have a horizontal reflection here. For the amplitude, that's going to be based on the a value. Specifically, it's going to be based on the absolute value of a. The absolute value of a, which is just 1 here, is just going to be 1. So for the amplitude, we're just going to say is 1. That means when we're graphing our function, wherever we're starting from, we're only going to move a maximum of up 1 and down 1 from that starting y value. Moving on to the period, this one's going to take a little bit more work, but this one is going to be affected by the b value. Now there's a formula we're going to use to figure out the period of these cosine functions. And that is going to be the period of these cosine functions is going to be equal to 2 pi divided by whatever the b value is. In this case, we're going to have 2 pi divided by 1, and that's just going to be equal to 2 pi. So the period for the parent function is just 2 pi. Moving on to the midline, this one's actually affected by the value of d, which is going to tell us if we have a vertical translation up or down a certain amount of units. In this case, d is equal to 0, so it says that we're not going to be moving up or down at all here. So we're going to say the midline is going to stay along the x-axis, along this horizontal line of y is equal to 0. Now the value of c, which is 0 here, would tell us if we are going to be translating our function left or right at all, but we're not going to in this case because c is equal to 0 and we don't have to worry about that. If c was some other number, that would affect our starting and ending point, but again, we're not going to have to worry about that in this particular problem. Now let's talk about the minimum y value and the maximum y value. To find each of these, we'll always start with the midline value and subtract the amplitude, so 0 is the midline. We're going to go ahead and take away 1, so 0 minus 1 is going to be negative 1. That's going to be the y value, that is the minimum y value for our function. And then for our maximum y value, we're going to take our midline, which is, again, 0. We're going to go ahead and add 1. That's going to be the highest value here. So 0 plus 1 is going to be positive 1. So that's going to be our maximum y value for this function. All right, so that's all the background information. Let's go ahead and just figure out where we are going to start and kind of end one cycle or one of these periods for this cosine function. So just kind of like giving it to you straight away, it's always going to be starting at 0 by default for the parent function. And because the period is 2 pi, then it's going to take 2 pi to finish a whole cycle. So it's going to end at 2 pi. So you can just kind of start by writing these down, and I'll go over where each of these are going to be coming from, but we can just start with this hopefully, and that makes sense. It's going to take 2 pi to make a complete cycle. Now, if that's going to start at 0 and end at 2 pi, then halfway would be halfway between 0 and 2 pi, which is just going to be 1 pi. So I'm going to say that we're going to be halfway through at pi. So if this is the starting at 0 and halfway point is at pi, then a quarter of the way must be in between those. So halfway between 0 and a full pi is going to be half a pi, so pi over 2. And then halfway between a pi and 2 pi here is going to be 1.5 pi, but I'm going to use an improper fraction and say it's going to be 3 pi over 2. Now, if you happen to be looking at this on Desmos or some sort of graphing calculator, you're going to see this as about 0. 2 pi is about 6.28. Pi is about 3.14. So if you're looking at it on maybe one of those graphic calculators and you're not seeing it in the, values of according to pi, you'll see decimals. And so don't be alarmed, but these are those decimal values. Okay. So these are our 5 really important points when we're dealing with our cosine functions. You're going to want to memorize these to help you out in the future. Dealing with other types of cosine functions where you have transformations, these will change, but by default, you're going to want to really know these as a baseline. So we have 0, pi over 2, we have a full pi, we have 3 pi over 2, and then we have 2 pi. So we're just kind of breaking up our cosine function into these important x values. Now, just giving you these f of x or y values right away, I'm just going to write it's going to be 1, and then it's going to be 0, then -1, then 0, then +1. If you are interested in where this comes from, then stick around for the next couple minutes of this video. Otherwise, if you are okay just knowing what they are, then skip ahead to where we're just graphing. So how do we know that when x is 0, then f of x is going to equal 1? Well, if you go ahead and take f of 0 or plug in 0 into our function, that's going to be cosine of 0. Now, feel free to look at a unit circle or think about what the ratios are, but cosine of 0 is going to equal 1. So when x is 0, then f of x or f of 0 is equal to 1. So that's where this is coming from. All right. Now, what about when x then turns into pi over 2? So this is pi over 2 here. So if you take cosine of pi over 2, this one's going to be at 90 degrees essentially. Then hopefully, if we think about where that is on a unit circle, that's going to be the x value. X value is going to be 0. So that's going to be 0 here. So that hopefully makes sense here. If we take a look at when x is equal to pi now, we're going to say, well, what is f of pi? So if we plug in pi in for x, that's going to be cosine of pi. So that's going to be on the negative x-axis on the unit circle. When you take cosine of pi, that's going to be the x value, that's going to be -1. So that's going to be over on the negative x-axis because that's the radius of that unit circle. And so that's going to make sense. That's the y value here. Next, what about when x is 3 pi over 2? So if we take f of 3 pi over 2, this is 270 degrees or the negative y-axis. So cosine of that 3 pi over 2. Again, cosine is going to be that x value, right? So at negative, or at that 270 degrees rather, the x value is 0, so that's going to be y. That's going to be 0 as well, okay? Moving on to the last one here, we just found out that that was going to be the point for when we have 3 pi over 2 for x. But what about when x is 2 pi? Well, that's going to be the same as when x is 0. Those are coterminal angles. So if we have f of 2 pi, that's going to be just cosine of 2 pi, but that's going to be the same value of cosine of 0, which we said earlier was equal to 1. So that completes one cycle here. All right, so I know a lot of the trigonometry can be a little bit intimidating sometimes, but just keep in mind after all this that we are really just dealing with some x, y coordinates, and these are the 5 points that we're going to want to graph for our parent function. So after you do enough of these, hopefully you'll eventually just kind of memorize them, so you can just go ahead and make this table right away or plot these points, but this is where the original 5 points are going to be. So let's go ahead and put this all together on the coordinate plane now. All right, so here is our x and then our y, or the same thing as f of x here. And here we've labeled the x-axis accordingly, so we just went by pi over 2 for each of these, but feel free to space them out however you would like to. I'm going to write a few of these periods out. And here are our y or f of x values. Typically, to get started, it's good to just start by sketching our midline, so that's going to be y is equal to 0. It's right along the x-axis for the parent function. And it's good to identify where our minimum and our maximum y values are going to be. So our minimum y value is going to be at y equals -1, and our maximum y value is going to be at y is equal to +1. So our cosine function is not going to go above or below these two y values. Alrighty, so let's go ahead and just start plotting these points. So 0, 1 is going to be right up here. So just try to remember in the future, cosine is going to start up here, not at the origin like the sine function. Then we have pi over 2, 0. That's going to be right along the x-axis here. After that, we have pi, -1. That's going to drop down below to our minimum y value. And then it's going to be coming back up here to the x-axis. So that's 3 pi over 2, 0. And then it's going to be 2 pi, 1. So it's going to move its way back up because this is going to complete one cycle. Let's go ahead and connect these points in a smooth curve for the cosine function. All right, so this right here is one period of that cosine function, but again, this is going to repeat itself forever and ever. These are just the 5 points that we had in our table. So what I'm going to do next is just continue this pattern by coming back down, then go all the way down to the minimum, back to the midline, then back to the maximum Y value. And then I'm going to also do this to the left of our initial period as well, and just kind of continue this pattern so we can see what this is going to look like. So definitely not necessary, but just something I'm going to do so you can see the pattern. So this is what it would look like if we sketched 4 of these periods out. Hopefully it feels just a little bit less overwhelming if you know that you're just kind of duplicating the same thing over and over. Alright, so that wraps up this pretty detailed video on graphing the cosine parent function. So if you found this video helpful, please consider giving it a thumbs up and letting me know in the comment section down below. And if you're looking for some additional videos dealing with all the different transformations, where you have some stretches and shrinks, or maybe some period changes, as well as some other types of transformations, check out my YouTube channel and you can see some more resources on those that are hopefully helpful. As always, keep up the great work that you're already doing, and I'll see you in the next one.